In this project, we'll apply machine learning to identify fake news related to COVID-19. We will start by evaluating the opportunity, introducing the problem selected as the project topic, and we will explain why we consider this to be an attractive opportunity for a machine learning-based solution. We will move on to define the problem, answering the questions included in the CRISP-VM template provided in the course, and we will define our outcome and output metrics. Finally, identifying factors which may be potentially relevant to our case. Then we will briefly describe the solution concept and explain how it uses machine learning, and we will also explain the iterative experiments to be carried out to validate the proposed solution concept. We will continue by exploring the considerations of the 3 machine learning system design decisions as pointed in Module 4 of this course, and for each, we will give an explanation as to why we have selected it. Finally, we will consider possible model issues which might arise with the proposed model in production. So let's move into the opportunity evaluation. So as we know, today a great amount of information is continuously created and shared online, particularly in social media platforms. Analyzing the information shared to correctly identify purposely fake information and rumors has become a primary concern by many journalists and users, particularly with the outbreak of COVID-19, where misinformation can lead to actions that can be risky for the individual and public health. Facing this situation, this project will propose an accurate model to detect possible fake news regarding COVID-19. So why exactly is this attractive for a machine learning-based solution? Traditional non-machine learning detection approaches have proven ineffective in social media due to the complexity and size of all information shared, and they are also very time expensive. With machine learning, however, this is not necessarily the case, and having already been implemented in the detection of fake news on some occasions, this approach has shown that they can overperform non-machine learning approaches. Our target users will be journalists, professionals, and social media users interested in staying informed of the latest news regarding COVID-19. Since these users commonly face the problem that the fake news and rumors are shared so rapidly that they end up confused and they are unable to differentiate correct and incorrect information, also affecting the work of journalists, of course. If fake or incorrect information is spread, users may end up taking decisions based on their incorrect understanding, risking their health or potentially breaking the laws applied by the local governments. Today, a big part of this fact-checking is currently performed using non-machine learning approaches, which slows the process and allows many fake news to be spread freely. With this project, we hope to minimize the spreading of fake news and maximize the accuracy in categorizing them as such. Our outcome will be the accurate classification of fake news, and our output will be the accuracy score and the area under the curve. We hope to improve our accuracy in the classification by a certain percentage, and the outputs for this would mean the accuracy score bigger than y, and an area under the curve as close as possible to 1. We will face the need to correctly classify as fake, not fake, as fast as possible to prevent the expansion of fake news. Our factors to consider will be time of posting, the specific terms and words used, the author's name, and the source. So in our solution, we'll proceed by experimenting with the classification of news datasets using the natural language processing techniques of bag of words and term frequency inverse document frequency, along with various algorithms. These news datasets can be found in online dataset repositories such as Kaggle. As explained earlier, we will evaluate the results by measuring the accuracy score and the area under the curve. So after obtaining a dataset, we will pre-process the dataset as needed to improve efficiency and eliminate noise. And we will use bag of words and term frequency inverse document frequency to transform the text into a document term matrix format, which will allow our machine learning algorithms to interpret the information. We will then train the dataset using an n-gram value of x. We will compare the accuracy score and area under the curve of both LightGBM and XGBoost algorithms, since these two machine learning algorithms have been used very effectively in other fake news detection projects. We will fine-tune this through the technique of hyperparameters to suit our model. Finally, we'll be able to evaluate the performance of both classification algorithms and compare their accuracy scores and area under the curve. In this case, since we'll be evaluating information shared by multiple accounts using multiple devices online, running our system in the cloud is preferred. Also, we would prefer online learning to offline, as well as online prediction rather than batch, due to the nature of the continuous flow of the new posts and news being shared. Finally, let's consider the potential risks in production. Training serving skew and data drift are probably going to be a factor of concern. New terms such as new names of variants or new labels and jargons can quickly be overseen by our models, since these will occur commonly and rapidly in texts and posts, and will likely not have ever appeared in our dataset during the training phase. It is more than sure that our data will need cleaning before training. We'll need to remove unwanted columns that add noise to our dataset, and we'll need to take into account that misspellings, symbols, and emojis may interfere with our processing both in training and after deployment. Thank you.